Okay, so this is part 3 of the enzyme required practical in biology. Briefly, the setup: water bath, 30 degrees. We know it's 30 degrees from the thermometer rather than from the dial on the front. I've got 3 different buffer solutions. The buffer solution we're going to use this time is pH4 value. I've got a 1% amylase solution, and I've got a starch solution in there. We also have, in order to indicate the presence of starch, we're going to use iodine solution. I've put 1 drop into each of the dropping tablets, and we're going to be using the pH4. Let's get that started. We've already seen what happened with the pH 6, which took us about 2 minutes to get back to the orange to indicate that the amylase had broken down the starch. So I've got 2 millilitres or 2 cubic centimetres of pH4 solution. Pop that back in there. I'm going to get 2 millilitres, 2 cubic centimetres of amylase solution. Just adjust that on the syringe. And as previously, we're going to put 5 to 1. I'm going to put 5 times the amount of starch in there for the amylase to break down. So we're going to put a total of 10 millilitres or cubic centimetres of a 1% starch solution. As we've done exactly the same method as previously with the other 2 parts, as soon as I put this into there, the amylase will start reacting, or should start to break down, should I say. It doesn't react as such, it starts to break down the starch. So as soon as I put it in there, I'll shake the test tube while I start the timer. So the solution goes in, keep that shaking and start. We're looking at every 10 seconds, put in a droplet of the solution in. There we go, we've got a strong purple indicating the presence of starch still in that solution that we've got. Again, we'll rinse in between with the clean water, 30 seconds. You can see already actually there's quite a change already starting. 40 seconds. We're still getting a reasonable purpley colour after 40 seconds. Keep rinsing and washing in between and stirring in between. 50 seconds there. 60 seconds. And we're actually getting quite a quick change, I believe, on this one. 1 minute 10. It's actually getting quite close, I suspect now. 1 minute 20, and I'd say we're getting very close there. 1 minute 20, 1 minute 30, and barely noticeable change, it's just that tiny bit darker. 1 minute 40. Slight indication again of the starch still being present. 1 minute 50. Probably very slight indication again. I'll take it to 2 minutes. And I would argue that we're getting virtually no change there now. We'll try one more at 2 minutes 10. Choose that. And let's just see, because there's a little bit of black in that one, but I would think that was 2 minutes 10 that was changed. So that is our result on this one. What you may be asked to do is to plot a graph in the first instance showing how the different pH values have taken a different time. I would say that that one has gone orange at 2 minutes 10, the pH4 buffer. So we could have pH on one axis and time in seconds. Remember, 2 minutes and 10 seconds is obviously 130 seconds, so we need to keep the scale the same. I'll just stop the clock. But we can see that arguably the amylase worked best on the pH 6 value, where it did it in about 2 minutes. When I say it did it, it had already broken down the starch, so we could no longer see a trace. The pH 4 was very close, probably 2 minutes 10, and we saw with the pH 8 quite an alkali solution in regards to the others. The pH 8, after 4 minutes, there was still clearly starch in there, so it shows the optimum value of the pH being probably 6. It would be interesting to repeat, maybe with a pH value of 5, to see what would happen there. But they should be a reasonable set of results for us to base some sort of conclusions upon. Thank you very much.